kind of questions came up on yesterday's extra practice? Yeah.
Number 17.
Number 17. Okay. So number 17, most likely when you have the A terms, they're a little tougher. Okay. So you're solving it by completing the square. First step, Kai, what do you got? Okay, so what do we do first, though? Put C on the other side. So 3x squared plus 6x equals 1. We add 1 to both sides. Okay, the next thing we want to do is get A to be a 1, meaning we have to divide every term by 3. So take note, if there's an A term other than 1, you want to divide by that. So you get x squared plus 2x equals 1/3. Okay? And then from there, completing the square, this x plus half of that squared. And then we've got to add the square of that to both sides. Okay, so we make our perfect square, x squared plus 2x plus 1, by adding 1 to both sides. And that allows us to factor this into that. So 1 in terms of thirds is 3/3. So 1/3, and we'll call that 3/3. 1/3 plus 3/3 is 4/3. Okay, take your butt out. Take square root, x plus 1 is equal to plus minus square root of 4 over square root of 3. All right. And then subtract 1 from both sides. So you get x is equal to -1 plus minus root 4, which is 2, over root 3. I would be concerned about the root being in the denominator, but you're going to end up just simplifying that and rounding to the nearest. I said you could go to the nearest tenth. It said the nearest hundredth on here, but you get x is equal to -2.2 and 0.2. Okay. Good question. Other questions? Yeah. That's fine. Yeah. Other questions? Yeah. 25. All right. Diver jumps off a diving board. You get that function there. H equals -16x squared plus 6x plus 5. Represents the height in feet after x seconds. What is the maximum height above water? So in other words, you need to find your vertex. This graph's opening down. Okay, so I'm fine with you finding the vertex using the method we learned yesterday. You could also, if that's confusing, you could also just take your equation that they give you and just do the opposite of b over 2a. Remember, your vertex is just -b over 2a, comma, f of -b over 2a. If you guys recall that. So one way to do it is just to find out what the x value of the vertex is by doing opposite of b, which is -6 over 2 times -16. That's -6 over -32, which is 3 over 16. Okay, that's this value. And then to find the actual y value, you're going to put 3/16 in for x squared. So you go h is equal to -16 times 3/16 squared plus 6 times 3/16 plus 5, and doing the math from there. Okay, when you go through and calculate that out, you end up finding out that it's 89/16. Okay, so 89/16 is approximately 5.56 feet. Okay. So the height is 5.56 feet. All right, that's the maximum height. In how many seconds? Well, that would be your 3/16, which is 0.19 seconds. So you're using that vertex that we used last chapter. So this becomes that. This one becomes that. Okay. Good question. Other questions? Okay. Let's go ahead and check our work. We did the odds. Number 1. I think we did as a class, but it's x plus 6 quantity squared. Number 3 is x plus 2 quantity squared. Number 5 is x minus 7 halves quantity squared. Number 7 is 3 and 5. Number 9 is negative 10 and 3. 11, negative 0.8 and 12.8. I went to the 10th on these. I know it said to the nearest hundred. So. Number 13, 11.2 and 0.8. Number 15, negative 11 and 9. Number 17 we did as a class, but it's negative 2.2 and 0.2. Number 19 is y equals 7. It's a maximum. 21 is y equals 14. It's a maximum. 23 is a minimum. Y equals negative 7/4. And then 25 we just did, but there's the other way to do it. Okay. I know that some of you have already seen that. Questions? All right, let's go back to our warm-up real quick. The warm-up. Why do I show it? Well, you'll probably see it on a test or quiz at some point. You'll definitely see it on an assignment. You decide to use chalkboard paint to create a chalkboard on a door. You want the chalkboard to cover 6 square feet and have a uniform border as shown. Find the width of the border. Okay, so here's your chalkboard. All right. So, if I'm going to find the width of this, tell your neighbor what you tried to do. Okay, what was your thought process? Yeah, you would. That would be good. Okay, back up here. No need for me. To find the area, how do you find area of a chalkboard? Or area of any rectangular figure? Yes? Length times width. Okay, I know I didn't spell that right. Is equal to length of chalkboard times the width of the chalkboard. So if you want to think of it like having a verbal model, this is what you're doing. Now, how many of you at least thought about that? You're like, I think that's what I should do. I should multiply the length of it by the width of it. So 2 of you thought that as eighth grade, really? All right, hey, that's a big concern, guys. Come on. How many of you found an area of a rectangle before? Okay. How many of you recognize this as a rectangle? And only 2 of you thought I should multiply its length by its width? Okay. How many of you, like, I don't care if you know the length and width, at least how many of you thought it's a rectangle, I need to go length times width? Okay, that makes me feel a little better. Okay? So, the difficult part is to find the area. Now, I know a lot of us don't like writing this stuff out, but this is a verbal model. Okay? It's saying what I need to do. It doesn't mean you know how to do it. It's just saying I know this is what I need to do. Okay? To cover 6 square feet, 6 square feet is what? Which one of these is it? That's our area. That is 6. The length, well, I can look at it. Well, here's my length. Well, the only thing I know is the length of the door. The door is 7. The chalkboard is how far away from the top of the door? You can't just randomly throw out numbers. It is this length, which is x. So it's 7 feet minus x. What's this length right here? It's also x. It says it's uniform, meaning the same measurement. Also x. So it's actually 7 feet minus x, which is 7 feet minus 2x. So the length of the door is 7 minus 2x. Is it in inches? Ooh. Round it to the nearest inch. Well, you know what we could do is, since this is measured in feet and this is measured in feet, we can go through and at the very end change it to inches. Okay? Good point, though. What's the width? Using the same idea of what I just did for length, what's the width? Tell your neighbor there. Okay, so we have the width of the door, which is 3, and you have to take off how much? X and X, which is 3 minus 2X. All right. Now, if you're going to solve for X, first thing you have to do, if it was equal to 0, it would be really nice. We'd be able to do that quickly, but it's not. It's equals 6. So you've got to multiply this out. I want everyone to multiply that binomial by that binomial there. Okay? Jason, what'd you get?
Okay, I got 21 plus 4x squared.
First part's right, 21.
Oh, is it not squared?
Yep, the back is right, 4x squared. Okay, so that's by that, but we're missing this times this.
Oh, snap-a-doodles. That's just, yeah, negative 14x.
And that times that.
6x. Negative 6x.
21 minus 20x plus 4x squared, all equals 6. So, okay, how do I solve those? Well, I have to, if I'm going to use completing the square, I've got to have it in the form of ax squared, that's the 4x squared, plus bx, it's 20x, and I've got to move this 21 over here by subtracting, right? So I get negative 15. Okay, from that point, I want you to complete this square. Actually, before we do that, we should do one more step before you should complete the square. Tell your neighbor what the step is you need to do before we complete it. Good job. Some of you had that before I did there. Divide by 4. Get rid of that a term. So we get x squared minus 5x is equal to negative 15/4. Don't worry about it being a fraction. And now complete the square. What are you adding to each side to complete the square? Yeah. Divide by what? Just 4. Yeah, just the a term there. Okay. Yeah, so you get x minus 5/2, which is 2.5. And you got to square that, right? So some of you are feeling much more comfortable with decimals, and I'm fine with you using them as long as those are terminating. And in this case, 15/4 is terminating. So if you wanted to write that as a decimal, what is 15/4?
Oh, I can do this. 6 and 1 4. 6.25.
3.75. So back there.
3.75. I'm smart.
I knew you were thinking that. Okay. And 5/2 as a decimal, what is it? 2.5. Okay. And 2.5 squared is what? What's 25 squared? 6.25. Okay. And that means we're adding 6.25 here and 6.25 here. Okay. What do we end up with on the left side of the equation now? 2.5.
Oh, I got it right this time.
Okay. What do I do now? Take square root. Okay. Now what?
Wait, so
okay. So if we're finding x, remember x is the width of the border there. Let's find it. What is 2.5 plus root 2.5 and minus root 2.5? About 4.08 and 0.92. Okay, those are approximations. All right, tell your neighbor what you're going to do with that now. You're not done. That only tells you what x is. Okay, what do I do with that? Plug it in for x, the width of the border, right? I want to go the width of the border to the nearest inch. If I plug that in, so if this is 0.92 inches, or feet, excuse me, 0.92 feet, what does that mean in terms of inches? $11.04. Okay, so the width of the border is 11.04 inches. What about the 4.08 feet? Should we use that as well? Can't have two different widths, but it's giving us two different widths. Why can't the width of the border be 4.08 feet? Yeah, it's longer than the door. Or the width of the door is only 3. Can't have a width of a border 4 feet. Okay? All right.